Okay, mathematicians, let's now have a look at the quadratic function, the graph of which, of course, is a parabola, and you're hopefully reasonably familiar with this. So we know what a quadratic function is. It's an equation of this format. If A is positive, the curve is concave up, so a smiley face. A is negative, the curve is concave down. When x equals 0 in this equation, then y equals c. So c is actually the y-intercept. So that's easy enough to read off. When y equals 0, so when this is 0, then we would just be solving a quadratic. So the values of x are the solutions or roots or zeros. It's called by all of those names as a quadratic. So that is, they are the points where the curve cuts the x-axis. Now to find these x-intercepts, we've got a few options, which we've already gone through. We can factorise f of x. So remember, y equals f of x. So we can factorise our quadratic and set that quadratic equal to 0 and then write down the x-intercepts. We can complete the square, or we can use this formula, which is of course just based on the technique of completing the square. The thing to remember is that when we factorise and we get the factors, we then look for the values of x which make the factors 0. They are the x-intercepts. When we use the formula, the values of x that we get straight up are the zeros. Now, parabolas are always symmetrical, and they're symmetrical about this line, x equals minus b on 2a. And that line, if the parabola has roots, and not all parabolas do, but if that parabola has roots, then it's midway between the two roots. The y value of this x, so in other words, the function of minus b on 2a, is either the top or the bottom of the curve. So that's either the maximum if the curve is concave down, or the minimum if the curve is concave up. That point, the maximum or the minimum, is said to be the vertex of the parabola. Now there's a lot of language there, but I'm hoping that you've heard all of it before. If not, again, this is something that you need to develop a little glossary for, so that you're familiar with those terms. The domain of the parabola, as we saw yesterday, is all real x, and the range depends on which way the concavity is. So it's all values of all real y which are greater than the minimum, or that actually should say greater than or equal to if a is positive, and less than or equal to if a is negative. So you might change those in your notes. They should be greater than or equal to and less than or equal to. So let's just have a quick look at a GeoGebra of the quadratic function. Again, more to refresh your memory than anything else. And then we'll have a look at the sketching process. So looking at our general form for the equation of a parabola, which is ax squared plus bx plus c. We've said already the value of a, depending on the sign, affects the concavity. Depending on the value, it affects how tight the parabola is to the x-axis. So if this is with a equals 1, b equals 0 and c equals 0, in other words, this is just y equals x squared, then if I increase the value of a, then the parabola gets tighter. And this is entirely logical because every y value is going up much more significantly. It's getting doubled. So the higher the value of y, the tighter the parabola gets. And when I go back down to 0, now at 0, it's not that we have got a straight line, anything like that. We actually don't have a parabola. So if there is no x squared, it's not a parabola. Now, when a is minus 1, our parabola is concave down, and again, as we go to bigger magnitude negative numbers, then the parabola tightens up on the axis. So I'll just take it back to 1, And if we look at the effect of c, because it's the next easiest to understand, if I have y equals ax squared and I add 1, 2, 3, it takes the vertex up the axis. If I add negative numbers, it takes the vertex down the axis. So I'll just put c equals 0, so it's not a distraction. What does b do? Well, b is not quite so simple. If the value of b becomes more positive, it shifts the vertex left and down. If it becomes negative, it shifts the vertex right and down. So we just need to have a vague idea of how that works, and the effect will really become much more obvious when we actually plot intercepts on the parabola. Let's have a go at sketching these parabolas. You need, as it says somewhere up above, to develop a flowchart in your head for sketching the parabolas. So as we look at them, the very first thing I think to notice is that it's concave up, so we know the general shape of it. It's going to cut the y-axis at -8. Now that doesn't mean that this is where the minimum is, because in fact it's got a value for b here. We know that's going to shift the vertex to the negative side, to the left, and we just now need to find where the vertex is. So we've got options. We can use x equals -b on 2a to get the axis of symmetry. So that would be -2 on 2 times 1, so -2 on 2, which is -1. So that's the axis of symmetry here at -1. We could then take the function of -b on 2a. So in other words, put that value of -1 into this equation and get the y value. So that would be -1 squared is 1, -2, -8, so that's 1, -10, so that's -9. So that sort of fits. The vertex is down here at -1, -9. We could have also found the axis of symmetry by finding, if they exist, the two roots of the equation. So they're the values of x that make this true. X squared plus 2x minus 8 equals 0. They're the values when y equals 0, which is when we cut the x-axis. So when we look at this, we try to factorise it. Are there two numbers that multiply to -8 add to +2? And there are. So x plus 4, x minus 2 equals 0. So that means when x equals -4 or x equals +2, we're going to cut the axis. So +2 is here, -4 is out here somewhere. And what we notice is that -1 is exactly halfway between -4 and +2. So our parabola in the full sketch is going to come down through 2, use your imagination, through 8, through that minimum point, and up there like that. For our next parabola, if we look at this, we can see by the negative that it's concave down. We can see by the +3 that this is where we cut the axis at 3. We have a value of b and it's negative, which means the vertex shifted to the right somewhere. Can we easily find it? Yes, well, I'm not going to go through the axis of symmetry this time. I'm going to check whether we can factorise it. So if I write this as minus outside of x squared plus 2x minus 3 equals 0, and then I focus on this bit in here, do we have two numbers that multiply to -3, add to +2? Yes, that would be x plus 3 and x minus 1. With this minus out the front. It doesn't really affect what the factors are, but we did this so that we could easily factorise it. So when x equals -3, out here somewhere, and when x equals +1, just there, they will be the points where we cut through the axis. Because a parabola is symmetrical, you can see we're actually going to go up higher. So I've just said it incorrectly at the start, but that's because it's concave down. So our axis of symmetry is going to be halfway between -3 and +1. So if we simply take the average of those, -3 plus 1 is -2. Divide that by 2, it will get to -1. So the axis of symmetry is at -1. The y value, when x equals -1, we can put it into this or this or this. It's probably easiest in this. So when x equals -1, this bracket will become +2. This bracket will become -2. So +2 times -2 is -4. And then this minus makes it a +4. So our vertex, which is called a maximum now, happens at -1, 4. So my parabola, and I'm very messy here, my parabola looks like that. Now, it won't take you much practice or to become refamiliarised with what you did in junior school, I hope, for these. Remember, it's possible that there are no roots, so the parabola is unable to be factorised, unable to be solved with the quadratic, and that just means it's entirely above or below the axis, which is fine. In that case, all we can do is find the vertex by axis of symmetry and function of that, and look at the concavity.